Hello, hello, hello. Once again, we are back for another episode of 10 minutes ago. Even though for the last few weeks we've always gone over 10 minutes, but it's the aspiration of doing it in 10 minutes. Today is episode 6. So, this is the sixth time we've been talking about Go, and for the sixth time, we've been going over what we would call basic and foundational information about Go. And we're going to continue today with some more foundational information about Go so that when you start seeing more complex Go code, you will not be lost. And if you are, go back and watch the first previous 5 episodes so that you will know what's going on. Again, this is an introductory series about the Go programming. And who am I? My name is Vladimir Vivien. I am a software engineer by day, and sometimes I've been known to write a few books. And I have written a book about Go called Learning Go Programming. And if you're interested in learning Go, please check it out and pick it up. Here's what we're gonna do today. Today we're gonna review what we did in the last episode, or episode 5. And today what we're going to talk about type definition. We've been talking about Go types in the last episode. We're going to continue with types and show you how you can define your own type. And then we're going to talk about the for and the if statements. These are control flow statements, and they allow you to change the direction of execution. So we're gonna, and very important in Go, we're gonna take a look at those. And the for loop, we're gonna look at how you can create for loop and for statements. And lastly, we're gonna look at type behaviors or methods. We're gonna show you how in Go you can add behaviors to just about any types, and basically add how that type would behave with logic. So let's go. So again, let's do a quick review as we've been doing before. In the last episode, one of the things we talked about was the struct type, and we showed you how to use it. Then we talked about arrays, and we show you how to initialize and use arrays, and talked about the difference between arrays and slice. We talked about slices, which is another type that is based on array but can grow in size. We also talked about map, which is a kind of, in other languages, you might have heard the term dictionary. And we talked about how to initialize map and how to use it. So the first thing we're going to talk about today is type definition. So let me switch over to my this, and we are going to talk about type definition. And here we go. Here's the first example of what I mean by type definition. Here, if you recall, in episode 5, we talked about struct, and one of the easiest way to use struct is to prepend your struct type with type and the name of the type and the struct, or the structure of the structure, right? But it turns out that the type keyword in Go is not just for struct. You can define your own type based on existing Go type. It doesn't have to be a struct. It could be an integer, it could be a boolean, could be a map. Just about any other type in Go you can use to create a derivative type based on that base type. And this is exactly what we're doing here. Here we see that we are creating a type called grade, and its base type is a float. And we talked about what floats are. And here we see another type called history, and its base type is a map of student. It is a map with key type being student, and it holds some integers. So as you can see, when you're defining your type, it follows one very simple pattern First, you start with a keyword type, followed by the name of the type and the actual type. So this is what we have here that I have highlighted. And it is the same thing here as well, where we have the keyword type, the name of the type, followed by the underlying type. Same thing here, keyword type, the name of the type, followed by the actual type. And when it comes time to using the type that I define, you just use it as if as any other type. So here, type student, we have it defined here. So I'm creating a value, a new value for and assign it to variable S1 of type student, and I fill in the name for the student and the GPA. GPA happens to be of type grade. Well, there's no grade type in Go, but we've defined it as being type grade here as being a float. So if it's a float, it's a decimal. It can take a decimal value. So that's what we're doing here. We have a GPA field in type student, and we assigning it 4.0, which this type is of type grade, which has underlying value or underlying type of float. So anyway, that is how you describe your own type. And you can do it with, like I said, with just about anything. You could come here and create a type called true and use the underlying bool type as its type. So true can now take either true or false, or you can come up and say type, let's say type description, and you could say that type, it has its underlying type as string. So as you can see, just about any type can be used to define a new type. Okay, so that's that. Let's go back to the, where am I? Let's go back to the slide. So next, we're going to talk about for and if statements. And these are what they call control flow statements. And what they allow you to do is basically create ways to change the way that the control of the program flows. So if you have for, you can create loops inside inside your program, or if you use if, you can change the direction of the logic of your program based on an if statement. So what? Let's flip back to our to this here. Now let's take a look at the loop first. Let's talk about loops in Go. The first one we're going to look at is this example. Okay, so and if you notice, as I'm getting deeper and deeper into the foundational basic stuff, I'm also combining knowledges that we've amassed over the last five episodes. So in this example, what we're doing is we're declaring a new type called employee, and that type happens to be a struct with name and title fields. Now we're going to create a slice of employees. Now we talked about what slice types are. They're arrays that can grow. If you need more information, check out the last episode. In this slice, we're going to store 1, 2, 3 employees. And then we're gonna assign that slice to a variable called emps. So we got employee 1, Vladimir, Marcus, Lena, and different titles. Now we're gonna use a loop to go through that list of employee and then print out that information for us. So here's how we do it. We're gonna use a for statement, and this is the for statement marks the starting of the loop. And as you're going to see today, there's different type different ways of using the for statement to create loops. So we're going to start with the more common way that you're going to see. And what we're doing is using the different portion of the loop to set up the for statement to set up the loop. In this approach, we have a declaration portion where we declare something, and it's more of a statement. So we have a statement. In this statement, we're going to say, I want I, or variable I, to be equal to 0. Next, we have a check. We want to make sure that we're going to check on the loop to test what condition is going to allow the loop to keep going. And the condition is, as long as I is less than the length of this slice, I want to keep going. And then we have an incremental statement that says, okay, what do you want to do to make sure that we move to the next iteration of the loop? We're going to do I++. If you're familiar with other languages, this is it's incrementing the value of I. Okay, so what this loop is going to do is start at index 0 because we talked about that in the last episode. Our slices and arrays are 0 based, so we're starting at 0, and then we're going to go all the way up to the length, which in this case is 3. But notice that we're saying it has to be less than it. So we don't want to go over 3, because if we do, then we're going to run into what we call runtime error, out of bound error, which when we run the program, it'll break because you're telling it to go to a location in your slice that does not exist. Okay, so if we run this, what it should do is go through from 0 to 2, because 0, 1, 2, those are the 3 elements in your slice, and we're going to be able to print it. And we are using a print function from the fimp package. We talked about that in past episodes. So if you don't know what I'm talking about, go check it out in previous episodes. Now, notice here, we are using the imps slice, and we're saying we're using the index notation that we talked about earlier in a previous episode to basically get to the ith element as we go through the loop. So, if we're at 0, then this would be imps 0, which would be this guy. And then we say, give me the name, give me element or field name, because we're stuffing structs in that slice. When we get to the ith element, it's going to be a struct. And I can ask for the field name on that struct. Same thing here. Imps is this, and I'm asking for the ith element, which is whatever the loop happens to be, whichever iteration it happens to be on. And I'm asking it to return title, which is the title right here. So let us let me run it in here. Should be able to see it. Okay, so I don't have to change windows. Okay, CD, which one is this? 6. Okay, we're gonna go run loop 1, and we see that it does exactly what we expected. It went through and printed all the elements that are in the slice. All right, let's go back to another example of a loop. All right, let's look at this guy, loop 2. Now here, this is pretty much the same program. However, we're gonna look at a different way you can traverse your slice. So when you're using the for statement, it has a special keyword that allows you to traverse slices and maps, and we're going to see maps in a little bit later. But let's look at how we traverse a slice. Okay, so now we're using for range. Those are the two keywords that we need to set up the statement. What range takes or expects, I should say, is either a slice, an array, or a map. And it knows, actually, there's one more, which is channel. We won't be talking about channel right now. But basically, when either one of those types are used with range and with combination with range, you're able to enumerate the elements in your slice or in your array or in your map or in your channel. Again, we're not going to use channel just yet. So in this example, we have emps, which is a variable, which is that has a slice stored in it. So because of that, we can use it as a parameter for range. And then what range will do for us is emit. And actually, I'm getting a little bit ahead of myself, but range is not only going to go through the slice for us, but it's going to emit some data for us. One of the data it'll emit is the position in the slice that we currently are at. So for instance, for the first pass of the loop will be at 0. For the second pass, I will be 1. For the third pass, I will be 2. So that's what we're doing. So again, this is basically the same example, except now instead of the full comprehension of for that we had before with the statement, semicolon, condition, and incrementation. Now we're just using range to kind of set that up for us. And if we run this program, it's going to basically behave the same way. It's going to loop over the element in slice in the emp slice, and then we can print. Now notice I'm using the same approach to do the print. I am using the index expression here for emps, put an index for I, and then pull out the name field and pull out the name title. So again, if we run this, let's run it here. All right, loop 2, it should be the same. Okay, so nothing major here. All right, I won't close it, so we'll stay on the same. Okay, now let's look at a third example for loop again. Now, remember when I said earlier that when you use range, it emits a couple of pieces of data. Well, in Go, range can emit two things if you're using if you're using slice, actually for pretty much all the types, slice, map, and channel, range can emit one thing or it can emit two pieces of data. When you're using it for slice, it can emit the index of where you are as we go through the as the loop is running. And then we can also emit a copy of that piece of data for that we have encountered for each iteration. So what does that mean? So here we are ranging over a slice, and each item in that slice has a value of a struct called employee. So what amps can do for us is not only give us the index, but it can also give us a copy of each employee that it encounters during that for each iteration. And that's exactly what we're doing here. We get that copy of employee and we put it in a variable called emp, EMP. And now we no longer have to use And we no longer have to refer back to the slice with the um, with a bracket and the index expression as we did before. Now we are getting the actual element that was encountered from the slice. So now we get an actual employee. So now we can just say emp.name, emp that title. And basically this is equivalent to the first example as well. So if we run this, we should get the same thing. Oops. So this is 3. And we see we get, oh, actually, I forgot to mention this part. We are actually also using I in this example to put a number, to put the index right before the line of information. So we see that we put I in the print statement, and then we put the name and we put the title. That is why the output looks like this. This is I, and then followed by the name and then the title, and so forth. Now, in a lot of cases, you may not even want I, okay? Because I might not care the position or want to print the index. So in that case, then there's a way where you can tell Go you're not interested in using I. So let's look at the next example, which is 4. All right, so now one thing Go allows you to do is to use what they call the blank identifier. The blank identifier tells Go, okay, I know that I need to put something there, but I'm not interested in that thing. Okay, so I just want this, but I don't want that. So Go will allow you to do that because Go is very picky about declaring something and not use it. So if I put I here and I don't use it, and then I try to run this, which one is that, 4? So it'll say, you declared I, but you're not using it, basically. So to tell Go that I don't care about I, but I do care about, we have to use the blank identifier. Okay, so now if I run it, you get the same example. You get the same output. All right, so we've seen how to use I with we've seen how to loop over slices. We've seen how to loop in general term using the full-blown format for 4. But while we at it, we're going to look at how to loop over a map, because a map is also something we're going to encounter a lot of time. And it happens that the 4 statement can be used to traverse your map. So let us go and look at the next example, loop 5. All right. Okay, so here, the example is slightly different, so let's look over it real quick. I have a type called histogram, and it just happens to be a map that takes a string as a key and a number as the value. Now, I think we've talked about that example before. And here we have a value called table of type histogram, and we have some data that we declare for that histogram. Now we're going to use the loop, the for loop with the range, for range, to traverse that table. And if you look, it's the same form. So remember I said earlier, when you reuse range, range has the ability to emit 2 values for each iteration for pretty much everything wherever we use it. So that's what we're using it here. What we're doing here, we're getting month, which is, in this instance, that's the key. So this is key and this is value. But I just went ahead and call it the month, so I know that it's this value. and we range over table, and then now we can print our values or the data. So month is the key, and then sales, which is the value, and then it's the actual value that's coming from the iteration. So now let's go ahead and run that. Let's see. Five. Okay. So you see that it went through and printed out everything that was inside that variable. One thing to notice is that it is not in order. That's one thing about map. The key, because the key doesn't have to be the type of the key can be arbitrary, really. It doesn't have to be a number, just like in slice. The way that the traversal happened is not necessarily in order. So as you can see, the first month that gets printed is October, November, March, April. Whereas if you look at the way we laid out the data in the histogram, in the table, we started out with January. So just remember, when you're using a map and you traverse that map with a for range statement, it's not guaranteed to be in order at all. All right, so that was, we talked about type definition. We talked about loop. Next thing we're going to talk about is if statement. Let me go. Let's close all others. All right. Let's look at if statement. Let me make sure how many. Okay, we only have one if statement. Okay. So if statement. If you have done programming in other languages, you should be familiar with if statement. And basically, it's a way of testing values as you encounter them. And if the condition that you tested is true, then you do something. Here's what we're going to do here. We kind of continuing on with the same example. What we're going to do is we're going to define a new function. Remember, if you don't know how to define the functions or the different parts of a function, go back to previous episodes. I've already discussed functions. So we've created functions, filter by month, and it takes two parameters. One is the value of the histogram. This is histogram. And then the other one is the month, which is a string that describes the month that I'm interested in. So what this function is going to do very simply is it's going to set up a new histogram, which is, again, it's a map. It's a simple map, really. That's what the histogram is. We're going to go and loop through the histogram that is passed to us and look for basically we're going to test to see if each month, which is a key, starts with a prefix that we're interested in. So for instance, here we're using a built-in package called strings, which has a bunch of utility functions around strings for us and built in Go. And we're going to use a function called has prefix. And has prefix is going to look at the value that I give it and to see, no, it's going to look at this to see if this value starts with this. Or actually, if this has this as a prefix, sorry. And if it does, we're going to put that in our result histogram. And then when we're done, we return the whole thing back. All right. So this is an example of an if statement. What we're not showing is that you can also have else. But because I don't care about the else, I didn't put it. But obviously, when you have if statements, you may care about the other side of the branch if the condition tests false. But in this case, I don't care because I'm in a loop. If we don't have a prefix that matches, then we just go to the next value. But it could be that I may have wanted to do something else. Maybe there was another bucket where I wanted to put values that don't match, but that's not the case here. So we ignore the else branch. Now, the other thing to notice about the if statement is that you don't necessarily have to put parentheses around the test statement. You don't we'll ignore that. But you do have to always, always, always start your if block with an open and close the block with a close parenthesis. Some languages will let you get away without, especially if it's a short one-liner statement that comes after the test, they'll let you ignore it. But Go always asks you to put that curly to start the block and then close it right here. So if we run this, what we're gonna get is this is if statement. So let's if we run it, we see that now instead. Oh, actually, one thing I need to show you is where I call this. This is where I'm calling this. And I wanted to show you the versatility of the language. So because filter by month returns a map, or it returns histogram, which is a map, then I can put filter by month right here. And because it's because this expression is going to return a map, then it's going to work fine. And here I'm saying, give me all the elements in the map where the key starts with J. Remember, we're using has prefix. If we were doing an exact match, I would have to provide the exact value that I'm interested in. But because I'm saying has prefix, then it'll find everything, all the values inside that map where the key start with J. So we have January, June. If we came here and say A, it should be just what, 1, 2, August and April. Sorry. And so forth. Or you could put an actual value. It should still work because of the has prefix. When it tests everything, it also tests to see if it's equal to the full thing. All right, so that's if statement. The last thing we're going to talk about are methods. And you may be like, well, what are methods? Well, we're going to see what methods are. Let's see here. All right. All right. Let's open this. Okay, so we only have 2. We should be able to cover it fairly quickly. All right, methods. Okay, what are methods? We've already talked about functions in Go. We see that you can create functions, you can add functions at the package level. Now, methods is a way to add a special type of function where you don't add it at the package level, but you add it at a type level. What does that mean? What it means is now you can add behavior to your type. Behavior meaning logic that now your type support. How does that work? Let's look at a very simple example. Here we're declaring a type called gallon. And that type has as underlying type a float, which is just plain number. And now I can attach a behavior to this type called gallon using what we call a method receiver. And this is what we're doing here. So the receiver is nothing more than an extra parameter that you can add to the method that tells it what type it is associated with. So in this case, it's associated with gallon. And the behavior that I'm inserting is I want, when I'm using that type, to be able to convert it to to quarts. So now, not only I have, when I create a value of type gallon, I can automatically get that value as quart. So let's see how this is used. So here, gallon, we have a variable called gal, and is of type gallon. Now, this is not a construct. You know, if you're coming from a different language, you may think, well, is this a constructor? What am I doing here? What is actually happening here? I am converting from type gallon. I'm converting this value to gallon. And because I say gallon's underlying type is a float, I can only put things that can be converted to float. So 5 can automatically be converted to float for me by the compiler. So can 5.0. Okay? Both the compiler will understand that, okay, I'm going to take that value, and because gallon is a numeric where I can convert from. So when it sees that literal, it'll say, okay, I'm able to convert that for you. Now, what gallon cannot do is to convert a type that it doesn't support. This is a string. Gallon does not support that. Gallon is a type float. So if I try to run this, it will break. So let's actually go ahead and try to run it real quick. God, I can't remember. Here you go. There you go. So let's. Okay. Alrighty. If I go run method 1. Okay, so it tells me that it cannot convert this literal, which is quote 5.0 quote of type string, to type gallon. All right, now let's put it back to what it was before, which is a number. And then now gallon is basically so I should say variable gal is of type gallon, and now gallon is a number that has behavior, that I've attached behavior to it. And now I can use that behavior to do things. And in this case, what I'm doing is to convert the value that's stored in gallon to quart. So now if I run this, it should tell me what the quart value is. That's all right. All right. And that's exactly what it did. So I hope that makes sense. I'm going to go to the next example, and then we'll look to see if there are any questions. All right, let's look at the next and last example. All right, this one. Okay, so this is, again, it's sort of the same type of example, but a little bit more elaborate. Because if you come into Go, you may be like, well, Go doesn't have object, or it's not object oriented, or it doesn't have classes, and all of that is true. But you can represent data, or you can represent value in Go that looks like objects, because you can have you can use something like a struct and attach behavior to it, so that now you can hold state of multiple values, but also attach behavior to that to those values via methods, which is kind of getting close to what an object-based programming is. We're not going to talk about how you can do composition and et cetera, but Go does allow you to embed different types into each other, so you can compose larger types. Anyway, let's go back to this. We see we have two types. One is called direction, it's a string, and the other one is called vehicle. It has a make and model as fields. And in vehicle, we are going to attach two methods. One is called start engine, and the other one is called drive. Start engine, just print, hey, engine is started, and drive pretty much does something similar. It takes a distance of float 32, probably should have been 64, but that's okay. And then a direction, all right? And we'll see how we use that down here. So we create a new vehicle, and we set the make to Ford and the model F-150. We start the engine and we drive, I guess, 10 miles in a direction north. Okay. Couple things to note before I run this example. Couple things to actually, one thing to note is how we're attaching the methods. In this example, we are using what we call a pointer receiver. And pointer receivers allow us to use the value to specify the value that we're generating or we're creating or we're instantiating here as a pointer. Now, and then once we have a pointer, we can use pointer receivers to update the different values inside our base value or base type. Why is that important? In a lot of places, actually, it's important in the fact that in Go, when you're passing values around, especially when you pass them inside, other functions, other methods, in certain instances, if you're not using a pointer, which is what we're creating here, by doing this, we're getting the pointer of a vehicle. And we didn't go too much into pointers. Just know that pointers allow you to update values in the original value when you use the pointer. You can backtrace, because you're going inside a function or inside a method with a pointer. Go can directly go back to that value and do the update. In some instances, if you don't use pointers to instantiate your value, you can run into issues where you do an update and the update doesn't reflect back to the value that you're expecting. So a lot of time, what you'll see in Go is, especially when folks are using when you're using structs in a object-based approach, you'll see that they'll use the pointer to instantiate the value, so that if I take truck and pass it somewhere else, that somewhere else will still be able to see the updated value of truck. I hope that makes sense. Again, at the end, I'm going to look at questions to see if there are any. So now, if we go ahead and run, go run method 2. We should see, there you go. So engine started. Notice that because this is a float, by default, this flag here in the printf, the float flag, prints as much. I don't remember what the default is, but it'll print as much position after the decimal point that makes sense for it. I don't remember. I think it's like 5 or 10. I don't remember what it is. And also because we're using float 32, it also limits it to, it looks like 6 decimal places. But I can, forget. I don't remember the format, but you can change it. Is it? So I think it's 0.2. I think it is, which says after the decimal point, go only 2 places, I believe. So let's see. There you go. Yep. Okay, so a quick recap. Um, we talked about, let's see, we talked about type definition. We talked about, um, actually, let's go back to this. We talked about type definition. We talked about for and if statements. We talked about adding behaviors with methods. And this is, for the most part, this should be the end of the fundamentals, of the basics. And from now on, we should be able to discuss Go and be able to build whatever we want and not get completely lost. And if you do get lost, you are welcome to basically go back in between the first and the fifth episodes and see what you've missed. So anyway, that is it. This is the end of the episode. I'm going to turn my attention to the questions now to see what we have in the channel. All right. What do we have? Let me scroll back here. Good afternoon. What's going on? Back to the team. Okay. I don't see any questions. Can you explain line 13? I'm not sure which example. So I'm going to ask, I think it's a question from Tammy, Tamika, Tammy, to tell me which example, line 13. But let me keep going. Okay, Kevin asked, are for and if the are for and if the only. So I'm guessing the question is, are for and if the only control or flow control in Go? No, there are a few more, a couple more. There's switch, which we didn't cover today, which is another way of doing testing and decision. And the structure of a switch is slightly different, especially if you have multiple values that you want to test, and each result of that test can make the program take different branching execution. So you can use a switch, but switch are also used in different contexts as well. Mainly if you can use switch to test the type of a value, so which we're not going to get into. So we have switch. There's one called defer, which we didn't talk about. And what defer does is very interesting. In a function or a method, you can tell Go to defer a particular statement and or expression. What Go will do inside that expression or inside that function is, when it gets to the end of that function or the end of that method, right before it exits and return back to the caller, it'll execute that defer for you. Actually, it'll probably make sense for me to show you. Let's see. So for instance, where is, I'm looking for a good example where it makes sense to, maybe it is the if statement is a better one. So what I could come here and say, defer, what's a good thing to do here? I don't know, defer print, sorry. I don't know, let's print the time. All right. So let me import time, otherwise it'll yell at me. Okay. All right, so now this is an if statement. So let me go back. Oh, sorry. tilde. Okay. I must be getting tired. All right, so let me go back to if statements. Okay. So what it did, I'm calling filter by month here. And filter by month is returning a map to me. But before it returned the map, it went ahead and printed the time, the current time. And it did that because I put defer here. So it did everything that the function is expected to do, including returning the result. But before it leaves that execution block, it printed that value for me. So I hope that made sense. All right, so we talked about switch and we talked about defer. Is there any? I don't think there's any more. All right, let's see. Any other question? Yes, switch is like case statement, somebody asks. Okay, Tamika cleared it up. Line 13 in the first example. Line 13 in the first example. All right, let's go back and see. I think the first example was the loop. Loop-de-loop. All right, first example, line 13. All right, what was the question now? Can you explain line 13? Okay. Yes, I can explain line 13. All right, line 13 here is, and we talked about, when we talked about variables, we talked about how you can declare the short way of declaring a variable, and this is the what we call the short form. We're declaring and assigning at the same time this value. This is the value we're declaring to we're assigning to emps. That value happens to be a slice, okay? And it happens to be a slice of employee. And this is what we're saying here. It's a slice of employee. Now, I could do something like, actually, to kind of make things even clearer. Let's do this. We could do this. Var emps employee. Okay. So this is kind of equivalent. We could do this. Excuse me. We could do this. So basically what I did is I declare emps to be of type slice employee. Now, when you do that, emps is nil. There's nothing in it. But we can add something at the next step. And that's what we're doing. We're initializing emps with this value. And in Go, Go supports what we call composite literal for the composite types. So employee is a composite type, and we can compose the value, which is what we're doing. We're compose the value of a slice of a struct. So what does that mean? What that means is I can do this. Okay, I can do this. This is legal, and the other way is legal. So what we had previously is a shorthand for this. This is the full-blown expression for that literal that shows you what's going on. I am basically initializing a slice, and inside that slice, I'm putting employee values. And each employee is of type, or each item inside that slice is of type employee. And I can now use the the literal form for employee, because employee, remember, employee is a struct. Okay, so I can use the literal form for employee to specify the value for each item inside that slice. So the first item is an employee, and this is its literal form. Actually, this whole thing is its literal form, where I specify the type, and then I specify open curly bracket, uh, field name colon value, and then separated by a comma, next field name colon value, and then I close the bracket. So this is a full defined value for the first item in my slice. Same thing for the second one, same thing for the third one. So at this point, right here, I have a slice, and again, the same thing with slice too. The slice literal starts here, and it's specified here that it's a slice and of type employee. And because it's a slice, I also have to open it up with a curly, and inside that slice, I have to specify each element of that curly. Now, I'm gonna create a new type just so it makes sense, just to show you what I'm talking about. Let's say here, and this is not going to be part of what we're talking about, but let's do something new just so you can compare the two forms. Let's say months, for instance. We can say months um, is a slice of string, right? And that is true because we're going to use strings to express month. But it's the same. We're going to do basically the same thing, the same form. Okay. Strings are expressed in Go as quote, quote, value, right? Jan, Feb, March, etc. So it's the same form as what we're doing up here. And if we go over this, we see that we have a slice, and that slice its element is of type string, and we start the slice with the open curly, and then each element here inside that literal value can be expressed directly as a string, which is what I'm doing here. So we have string 1, that's the first element. String 2, that's the second element in the slice. String 3, that's the third element in the slice. So now at this point right here, we have months has 3 elements in it, and each one of them is of type string. So it's kind of the same thing going on here. We have a slice of employee, and we start the slice here, and inside inside that bracket, that curly bracket, we can start putting the different elements for that slice. So because we say it takes employee, so we're going to put employee 1, employee 2, employee 3, and we could have kept going. One more thing, just to make sure that there's absolutely no gaps in understanding. We could have done this way as well. Actually, let's do it like this. That's one way we could do it. We can start with an empty slice, just to show you that this means an empty slice because I'm not specifying anything in it. And then on the next line, I can come and say, but because we're not specifying an initial value using a literal like we had before, now what I have to do is say, yeah, we have to do the append months. So this is also equivalent, or we could have done this. Now, okay, so let me kind of explain what I just did. Even though I initialize months, I initialize it as an empty slice, which means it has zero size and zero capacity, meaning that I cannot make reference to anything inside that slice. Otherwise, at runtime we'll get in trouble. But what I can do is use a pen to grow that slice. That's what we did, and we could have done this like this too. And this is basically saying we have a variable months, and it's of type string, and it's completely uninitialized. It's zero. Um, um, it has zero. It has a nil value really, and then also I have to use a pen to append values to it. So you can do this, or you can do this form if you know ahead of time the values that you have. Okay, that's a lot of explanation. I hope that made sense. Okay, let me see what else we got. Get the yes, please. If you're enjoying what you've been watching for the last 6 episodes, for the last 5, and this episode, definitely likes it. Tell your friends who are looking to learn about Go. Check it out. Let me see if I have anything else. With pointers, a variable can reference another variable by its memory location or current value. It's the location. So if I make sure I'm reading that question from Kevin, yes, pointers point to if we talked about the structure of what's going inside the memory, what we call the memory model for Go. When you're using a pointer, the pointer is not the value. The pointer is pointing to a place in memory where the value is. And that is why you can go in and out of context for that value and still be able to refer back to that value. So you can go inside multiple functions, past that pointer, go inside multiple method, past that pointer. When each function and method changes the value that the pointer is pointing to, that change is visible or is viewable by the different places where the value is changed, because we're not changing the pointer, we're changing where it points to. So hopefully that makes sense. All right, not that. Okay. Oh, I think I explained the wrong thing. All right. Since we're running out of time, let's see what else. All right. So I think we ran out of questions. And again, thank you. I think, this is probably the longest show we've done. I thought it was going to be the shortest, but I was wrong. Anyway, thank you for this episode 6. Looking forward to episode 7. Like I said, after today, we're just going to write straight code, build. We're going to use Go to build stuff and learn how to build stuff. I don't know what that stuff is going to be, but we're going to figure out some stuff to build with Go. And from now on, we're not going to be talking about the fundamentals. Although there's still some concepts we haven't covered, like concurrency and channels, etc. But what I'll do is we'll build things around these types of concepts so they make sense. Okay, let me see. I think that was the last word. Thank you, and see you next Saturday. Bye.